Hello students. Now we are looking at part 3 of general search algorithm. Okay. There are other two parts to this video. Please check that and come to this third part. Now I'll quickly sum up what we have seen the other two parts. One is core components of a search problem. We are talking about general search algorithm. So we are talking about core components that are there in general search algorithm. Second is what is the framework that is used in general search algorithm. Third is the tree concept that is there in the search algorithm. Today we will see fourth and fifth how specific algorithms evolve from a general search algorithm. Fifth one is evaluating search algorithm. Quickly, I'll cover the first three and get into the fourth one. One is the core components. What are their initial state, actions, transition models, whether the goal is met, and the path cost that to reach the goal. This is the core components. Second is the framework of a general search algorithm. The first is to initialize a data structure called frontier. It is an open list and there will be an export set where it is a closed list. Third is the goal state and how it explores through that to reach the goal. This is the third one. Now, every AI search is converted to a tree, search tree, and it's basically a data structure. So that is what is this tree concept is. Now let's get into the today's video where how specific algorithms evolve over general search algorithm. How does it come to a conclusion of how to go about searching? Now, basically, what it does is it forms a data structure as a tree structure. Okay, it could be a FIFO, first in, first out. What is FIFO? It's basically a stack. One, two, three, four, five, six. Six elements are put inside a stack. First, it goes in like this, comes out like this. First in, first out. This is FIFO. Basically, if this data structure is used, then it chooses breadth first search algorithm. And this is a uninformed type of search. What do you mean by uninformed is it's a blind search, meaning the path cost and the goal state is not known to the search. A search doesn't know the goal state and the path cost. Okay. Second is last in, first out. It's the same stack, but what happens here is last in comes out first like this. It's closed at this point. So last item that we put inside a box, assume an empty box, last item that you put here comes out first, obviously, because this end is closed. This is a data structure type, okay, which you might have learned before anyway. Depth first search, this is DFS. And this is also a uninformed search, which means the goal is not known. The path cost to reach the goal is not known to AI. Third is priority queue. It goes by the lowest path cost that is available. Here, uniform cost search is there. For every path, there is a cost that is fixed. This is also uninformed. Okay, next is priority queue by heuristic evaluation. Heuristic function is given here. So f of n is equal to g of n plus h of n. This uses greedy best first search. Okay, this is informed search, which means the path cost is known. Okay, that's why it is using a heuristic function to calculate the cost. Okay, I have given videos about separate videos for greedy best search and A star search. Please look in the playlist videos. You might get a for both these. I have shown given videos. Okay, now let's talk about priority queue. Priority queue is again informed search and it is a A star search which uses this function. Okay, now what we'll have to understand in this is for a specific data structure type, the resulting search algorithm is fixed. Okay, now the data structure that is taken will implement this search method by AI. Okay, then the elements, see how will you evaluate search algorithm, which is better, which we should use. All this as AI engineers, how do they measure? They have four elements: completeness, time complexity, space complexity, optimality. So let's look at each of this. What is completeness? Is the algorithm guaranteed to give a solution for us? Will it find a solution? Will the search give a solution? Of course, that's a basic thing. You ask an AI and it should give a correct answer. So that is guaranteed solution to a search problem. That is the completeness. That's the first thing. Second is time complexity. What time it will give? It should not take hours. It should give at a minimum time that is required to give a solution. That is the time complexity. Third is space complexity. What space complexity is? How much memory does it require to process this search? As AI engineers, we should be looking at all these four elements. Okay. Fourth one is optimality. What is optimality? If there are two solutions, assume there are multiple solutions for a problem. Say, let's say someone is asking for a cat image. There could be multiple image. We should give the highest quality solution, best possible solution we should give it. So that is optimal solution. Okay. These four are the evaluating elements for a search algorithm. Hope you understand what evaluating search algorithm is. So to sum up all this, general search algorithm is, first we talked about components where there are four states: initial, action, transition, goal, and the cost that is involved with the states. This is components, core components of a search problem. Then comes the framework. How it will work? It creates a data structure called frontier. Then it is a open list and there is a closed list where it is explode the branches. Then there is a goal state where it loops through and finds the goal state. This is the framework. Third is tree concept. Why we need to know a tree concept is because any problem is converted to a data structure. So we need to know what a tree concept is. Okay. Next is, today we saw about how algorithms are, specific algorithms are implied with data structures. If it is FIFO, first in, first out, breadth first. Last in, first out, depth first. Priority queue with lowest path, then uniform cost search. priority queue with heuristic function, greedy, best first. Priority queue with total cost, A star. Okay, for these two I have given separate videos. You want to check, please check. And this is the third part of the video. The other two parts are in the playlist. Thank you for watching, and please subscribe to my channel so that you can watch more videos. Thank you.